Dear students, in this class we will discuss about nicol prism. From one of our lectures we have seen that the polarized light can be produced by different method. One method is reflection, then refraction, then by using nicol prism, then by the selective absorption. From the method of the refraction, we can generate plane polarized light by using pile of plates. But in these methods, we can generate the plane polarized light with low percentage of polarization, or the intensity of the polarized light is pure. But one method is to produce the intense polarized light is we can use large number of the glass plates by method of the pile of plates. One of the good method for producing the highly intense plane polarized light is nicol prism. It was invented by William Nicol in 1828. So the nicol prism is named after his name. Actually, it is based on the principle of double refraction. We know that the double refraction, that is also known as birefringence. When a ray of light that is arrives at an anisotropic crystals, what happens? Definitely it is split into two components or two rays of polarized light. We call one ray as ordinary ray and another ray is extraordinary ray. Ordinary ray obeys laws of refraction. Extraordinary ray does not obey laws of refraction. In short, we write this ordinary ray as O ray and extraordinary ray as E ray. And keep it in mind is that the birefringence, it is not observed along optic axis. Optic axis means it is a direction, not an axis. Don't confuse with this name. Optic axis, it is a direction along which both the rays, that is extraordinary rays and ordinary rays, travels with the same speed. This nicol prism, it is made up of the crystals, calcium crystals, that is CaCO3, whose length is 3 times its breadth or thickness. Length is 3 times its breadth. And what is the principle behind this nicol prism? That is a double refraction. So when a ray passes through the calcium crystals, it definitely split into two components. By the speciality of nicol prism, this here, the ordinary ray, that is eliminated by the principle of total internal reflection, and only the extraordinary ray that is transmitted through the crystals, that is only extraordinary ray that is emerges out the crystals. We are coming detail into this section, that is the principle of the total internal reflections behind the nicol prism. Before that, we just recall the last topic. This is the calcium crystals, and I have drawn in red color, that is the principal plane or principal section. It is nothing but it is a plane containing the optic axis and perpendicular to the two opposite faces. Here we consider two phase, one phase and second phase, and perpendicular to these two faces, and it contains the optical axis, and also draw the plane along the blunt corners. For every point inside the crystal, there are 3 principal planes. In the crystal, it has 6 faces. So each pair of opposite face, there is the possibility of for the one principal section. So in these crystals, there are three principal sections. So this principal section cut the surface of the calcium crystals. It is in the parallelogram shape with an angles of 109 degree and 71 degree. Now how can we convert this nicol prism, or then how can we convert these calcium crystals into nicol prism? For this we have just grind the ends face of the crystals. End face are grounded. Grounded means grinded, so that each of the above angles becomes 68 degree. That is, here we turn this 71 degree to 68 degree, up to which the angles 68 degree we just grind the crystals. And now we cut the crystals in such a way that we cut along its plane perpendicular to the principal axis and also perpendicular to the end face. So we will get two pieces of the crystals. And now what we need to do, we just polish the end faces and just cemented these two pieces by using a thin layer of Canada balsam. Now this crystal is called as nicol prism. And one more thing we need to do, the sides of the prism, they are coated with the lamp black. This helps to absorb the light. And I have drawn the nicol prisms and one principal section. So just grind the crystals up to, that is, this 71 degree turns to 68 degree. So when an unpolarized light is incident on the nicol prism, what happens? It is split into two components. One is extraordinary ray and another is ordinary ray. See the details of the calcareous crystals for the ordinary ray and Canada balsam and extraordinary ray. The refractive index of calcite for ordinary ray, that is denoted by NO, that is 1.658, and the refractive index of Canada balsam, that is 1.550, and that of the extraordinary ray, that is 1.486. See here the ordinary ray, the refractive index is 1.658 and Canada balsam is 1.550. So definitely light comes from the denser medium to the rarer medium. So what happens? The light gets reflected. If the light is incident at an angle greater than this critical angle 69 degree, there is the possibility of the reflection of the ordinary ray. Here refractive index is greater than the Canada balsam, so light comes from the denser medium to the rarer medium, and also depends upon the angle of the incidence. If it is greater than 69 degree, definitely it gets reflected. And then what about the extraordinary ray? The refractive index here, just note, here the refractive index is 1.486 and here it is 1.550. So the extraordinary ray, that is not affected, as is travels from the rarer medium to the denser medium. So it gets transmitted through the prism. So we can say nicol prism, it is one of the good method for producing the plain polarized light. It acts as an efficient polarizer. Okay, we just conclude this nicol prism. It is an optical device used to produce plain polarized light, highly intense plain polarized light. Here, when unpolarized light is incident on it, what happens? It splits into two components. The extraordinary ray, that is only allows to emerges out the crystals. Why? Definitely it comes from the rarer medium to the denser medium. That is based on the refractive index. Then what about the ordinary ray? The ordinary ray, the light comes from the denser medium to the rarer medium, and also if the angle of incidence is greater than the 69 degree, it gets reflected. So the total internal reflection occurs in the case of the ordinary ray. And if we got lamp black to one side of the crystals, so this ordinary ray that is absorbed by the lamp black. But this nicol prism, it has certain limitations. If the angle of incidence is less than 69 degree, what happens? Definitely there is the possibility of emerging the ordinary ray out the crystals. So in that case, both ordinary ray and extraordinary ray emerges out the crystals. So the refractive index and also the critical angle of incidence play crucial role for obtaining the plane polarized light. Okay, in the next class we will discuss about retarders.